Okay, guys, we're going to go over notes from 8.2, but before I start those, I want to tell you from 8.1, the mean value theorem for integrals is not on this AB section, even though it's in those notes. It's not on the AB section. But there was the mean value theorem from Unit 5. That is one of our standards, and we did that in Unit 5. So you may want to go back and look at that to make sure you know that, because it will be on the AP test, at least usually it is. So we are doing position, velocity, and acceleration again. Now, I hope that tells you that this is going to be on the test. And they usually use S of t when the object is going up and down, like you drop something off a building. They usually use S of t for position. A lot of times they have story problems about a bug crawling left and right on a window sill. When they do left and right horizontal movement, it's usually X. So, we've had all of this stuff, but I put it on there again. So you're supposed to know that S prime of t is velocity. Okay, and then if you do the absolute value of t, that's the speed, because speed's always positive. Total distance is the integral of velocity, a to b, but it's the absolute value as total distance. In other words, if your bug crawls right 3, let's say it crawls right to the right 3 and then turns around and crawls back left 2, okay, that means its total distance it traveled is 5. It would be the absolute value of 3 plus the absolute value of -2. Now, when you take that absolute value off, that's displacements. That's where does the object stop. So let's say if it starts here at 0 and it went 3 right and 2 left, then the displacement would be 3 minus 2, meaning that it ended up at 1. So displacement is where it ends up, but the total distance is how far it traveled completely. Okay, and then S double prime is the first derivative of velocity, which is acceleration. And something else I want to make a point of right now, because it'll probably be on the AP test, is if an object's speeding up or slowing down, you have to do both velocity and acceleration. And if they have the same sign that's speeding up, if they have different signs, the object is slowing down. That was that deal I did in class where I was shoving someone in the back a little bit to speed them up. The position function in feet is -16 t squared plus the initial velocity times t plus the initial height of the object, or altitude. So like if you're dropping something off a 400-foot building, then that 400 would be that. And if you, let's see, and also in meters, it's -4.9 to -4.9 t squared plus initial velocity, initial height. But this would really probably be initial position. Well, it could be either. So velocity, v sub naught is initial velocity. If you throw an object up in the air, that's a positive. If you throw it down, it's a negative velocity. And as something moves right, again, if velocity is greater than 0, it's moving right. Velocity less than 0 is moving left. Velocity greater than 0 is up. Velocity less than 0 is down. And an S sub naught's initial height. So those are things we've already covered, and we're going to do them again today. Okay, so this talks about what we've already done. So it says your teacher moves along a straight line in front of the classroom according to the table below. Time is measured in seconds. X of t is the position of carpet squares they're covering. So this is how many carpet squares they're moving along. How far was your teacher ending position from the starting position? Okay, so we want to, in other words, from 0 to 4, we're asking what's this is displacement. In other words, where did they end up? So if you look at time 0, they were at the second carpet. At the time 4 ended, they were at the 18th carpet. So how far did they move, or what was their displacement? In other words, from where they started to where they ended, their displacement would have been 16 carpet squares. 16 carpet squares. Okay. Down here, this says, what is the distance your teacher moved? Well, distance, like we just talked about, is absolute value of all these added together. So absolute value of 2 plus absolute value of -2 plus absolute value of 0. She didn't move any there at second 2. Plus absolute value of 2 plus absolute value of 18. So the total distance she would have traveled would have been 26 carpet squares. Okay, so I hope you understand the difference between displacement and total distance. Okay, this next problem is calculator problem. So I've already typed this into my calculator, but we're going to do this thing here together. And I'm going to show you what to type into your calculator, even though I've typed it already into my Y1, because to me it's kind of a big deal to do that. So this says a particle moves in a horizontal line and has the velocity of this velocity right here in the position of s of t. Now it says it's known that s of 0 is -3. So that means this particle started at -3, like maybe you might think of a number line. This particle is starting out here at -3, okay? Find all the values from 4 to 7 in which the speed of the particle is 5, okay? So this is kind of a little bit of a hard problem because we want to find out everywhere the speed is 5. So what we want to do here is, first of all, we need to know that speed is the absolute value of velocity. And we want to know when that equals 5. So here's what we're going to do. I'm going to bring the camera over here so you can see what I'm going to do with my calculator. And I'm going to show you what I'm doing here. Okay, so I'm going to just show you that I already typed in my y equals. There's the formula. I already typed that in so I'd have it in there. And I hope you know that I talked about it a little while ago, but speed is the absolute value of this. So what I'm going to do is I'm going to graph this. I'm going to graph the speed of this thing, which is absolute value. So how I'm going to type that in is I'm going to hit math, and arrow to number, arrow to the right number, and that ABS is absolute value. So I'm going to hit enter. So there's the absolute value symbols, and I've already got the equation I need the absolute value of. So I'm going to hit vars, y vars 1, and put y1 in there, and that is that function. So I'm going to come up here and turn this one off because this is displacement, or this is speed here. That's velocity at top. I want speed, so it's absolute value of that. And I want to know when that equals 5. So I'm going to put 5 in there. Now, something else we should take into account here, which I'm going to make this disappear for a second, is this problem is talking about 0 to 8. Okay, 0 to 8, but this part's only talking about 4 to 7. So I'm only worried about my t value from 4 to 7. Now, if I'm looking at the whole picture, I'm going to go 0 to 8, but in the problem, they're asking me only 4 to 7. So when I go back and get I'm going to go to my window, and I want my window to go from 4 to 7. So I put 4 and 7 in there for x. And I'm going to come down here and make I'm going to go -10 to 10. And I'm going to graph it. So that's only 4 to 7 right there. So that thing going across my screen right now is that sine graph. So we're going to look at that from 4 to 7. And that looks pretty funky. Got a little sharp turn right there. And here comes my 5. So we got 2 answers for this because those intersections are my 2 answers. So I'm going to hit second calc, number 5. And I'm going to move it over by that intersection, and all I've got to do is hit enter 3 times. So the first one, it's on the red when you hit enter, and it jumps to the blue, and I hit enter, and I hit enter a 3rd time, and it's going to give me that intersection. And we have to have the 3 places. So we're going to round this to 3 places, so that's 5.621. And I'm going to write that down so I don't forget it. So t equals 5.621. And I should look up here to see what the time is in terms of, and it really doesn't tell me what time, so I'm just going to leave it 5.621. And there's another one, so I'm going to go back to my calculator, and I'm going to hit second calc 5 again, and I'm going to now take this thing over by the other intersection. And I'm going to hit enter, enter, enter. And there's the other one at 6.520. 6.520. 6.520. So if you notice, these are between 4 and 7, right? So these are the two times that the speed of the particle reaches 5. All right, we're going to write the expression involving an integral that gives position. So I hope you know that this is velocity, we want position, and we want to use the expression to find the position of the article at t equals 3. All right, at t equals 3. So we're going to be moving from time t equals 0 to 3. So that's going to be the integral of 0 to 3. And I'm just going to put velocity because the integral of velocity, you could write this whole thing in there if you wish, but I'm just going to use velocity instead of having to write that whole thing out. And we're looking for position. And I'm going to move this thing kind of over a little bit at 3 because this thing comes into play right here because we're not starting at 0. We're not starting here. We're starting at -3. So we need to put that -3 plus, this will be the amount we move from 0 to 3. But we're starting here, so you need to put the starting point down here. And that equals this. Okay? So, and another way to think about this is if I do the integral from 0 to 3 of velocity, dt, that is s of 3, position at 3, minus s of 0, okay? So again, if we plug in -3 right here, this is actually +3, right? And if I subtract that over to this side, you see s of 3 equals this thing. And that's another way to get it. You can use the fundamental theorem of calculus to get that if you wish. Okay, so I'm going to type that into my calculator. So I'm going to show you how to do that. Get my calculator picture back up here. Okay, so I'm moving it down so I can see what to type in. So when I type this in, I'm going to have -3 plus, and then I'm going to hit math 9. Math 9, 0 to 3. And if you remember, that is my y1 value. So I'm going to hit vars, y vars, 1, 1. I'm going to plug it into that original function. And we're doing x instead of t on our calculators. And I hit enter. And there's my answer. So the position at s of 3, the position at t equals 3 is going to equal that -6.263. That would be my position at 3 seconds. At the exact time t is 3 seconds. Okay, let's keep going. I think this is going to be a little bit of a long assignment. All right, now part C says find all times in the interval from 0 to 8. So I'm going to have to change my window that the particle changes directions. Now that's velocity. So we're supposed to know when velocity is less than 0. Remember, this is moving horizontally. It's moving left. The object, the particle is moving left. And when v of t is greater than 0, the particle is moving to the right. So I am going to show the velocity graph. So I'm going to come in here and I'm going to turn off these two things that I used to find the other part. And I'm going to turn that on. And remember, I got to go from 0 to 8 now. So I'm going to change this from 0 to 8. And I'm going to hit graph, but I'm only graphing that first equation. So here it comes from 0 to 8. Oops, let me pause this because I just now saw that I did not put the camera up there. Sorry. So all I've done is I went in here and I shut off these two because this was about speed here. But this is this is the object's velocity here. So I'm going to graph that thing. So I'm going to continue here. So here comes the graph of that thing. And remember, that is velocity from the equation. And again, this is from 0 to 8, from time t equals 0 to t equals 8. So there's my function right there. I don't need to see what happens below there yet. So velocity is negative to there, positive to here, negative to there. So what that means is the object starts moving left, then it moves right all the way to here, and then it moves left again. So I need the zeros the value of the zeros are going to be telling me when the object is moving left and right. So I'm going to hit second calc, and I want number 2 now. I want the zeros. So I'm going to hit the number 2, and I'm going to come over here and find this one on the left first. So I get both to the left of where it crosses, hit enter, get to the right of where it crosses, and you can look at the signs down here to see when they go positive. Hit that one and hit enter again. So my first 0 is 2.341, 2.341. So I'm going to put t equals 2.431. Okay, and then I'm going to go back to my camera and find the other one. So I'm going to hit second calc 2 again, but now I'm going to take it over there by the other 0. Hit enter before I cross it, then cross it, hit enter, and enter again. So the next time it crossed is 6.127. So I'm going to write that down. 6.127. Okay, so those are the 2 times when the object was 0. Okay, so find all the times on that interval in which the particle changes direction. Justify your answer is going with this stuff up here. So, and we want to find all times it is that way. So what I would want you to do is I would like you to put this in, put these things in time. So in intervals. So I would like you to say from 0 to 2.431 and 6.127 to 8. And remember, we're only going from 0 to 8, right? The particle moves left. Because v prime of t is less than 0 on those intervals. And then we would want to say from this intersection to this intersection, from 2.431 to 6.127, the particle moves right because v of t is greater than 0. It's above the x-axis on that graph. I'm going to show it to you again here real quick. Clock things going off. So if you look, negative to that first intersection, positive to that one. And you could have also said these 2 answers. You could have said t equals these 2 answers because v of t changes sign at those 2 t values. All right. This last one says, is the speed of the particle increasing or decreasing at t equals 7? So we want to know, are we speeding up or slowing down at t equals 7? So if you remember, we talked about that a little while ago. I'm going to have to find velocity at 7, and I'm going to have to find acceleration at 7. And if they are the same sign, the object's going to be speeding up. If they are different signs, the object's going to slow down. Okay, so I'm going to take my calculator here. Oops, let me get the camera back up here. Move it out of the way. Move it over here so we can see what we're going to be finding. And I'm going to go back to my graph. Okay, so that's the velocity function. So I want to find v of 7. So I'm going to hit second calc number 1. And I want to know the velocity of 7. So I type 7 in there and I hit enter. And that is negative 10.912. Okay, so this is negative. So this means the object's moving left at v of 7. Okay. And then, oops, I need to put the camera back up there, sorry. Now I need to find the derivative of velocity. So here's what I'm at 7. So what I'm going to do is I'm going to quit this picture. I'm going to hit second quit. Oops, I don't want that. Go back to this screen, and I need the derivative. So I'm going to hit math 8. And I want we got this in terms of x. That's my velocity function. So I'm going to hit bars, y bars, 1 and 1. And then we want the value of that derivative, which is acceleration. I type in 7 there and hit enter. and that's negative 10.561. So that means the acceleration is also negative. This was me pushing the person in the back. Walking left, pushing left means that the particle is speeding up. At t equals 7 because b of t is less than 0 and I should say b of 7 actually. If you put b of t, it would not count it wrong. A of 7 is less than 0. So there's the reason for that one. Okay, we're going to keep going here and see. Oh, this whole thing right here has got some of that stuff I put down. I did not look at all the notes before I started writing stuff down. So he's actually got extra stuff in there that I did not cover, but you can read through all this. If you have questions, please ask in class. That's all that information. And then we get to this problem. Not sure, I can't remember what example it is, and I cut it off. But anyway, the Space Yacht is an amusement park ride that gently raises riders up to a tower and then rapidly bounces them up and down using compressed air. The velocity from 0 to 14 is modeled in this piecewise function. I'm going to put a B here to remind me this is velocity from t equals 0 to 14. And if you look at this, these are all geometrical figures. So what I'm thinking right now is I'm going to get area to find position with some of these, and we'll see what happens here. So part A says, at what time does, from the interval from 0 to 14, so all the way across, if any, does the Space Yacht change direction? So we just talked about this on the last problem, right? So anytime it changes from positive, the function changes from positive to negative. So I'm looking for zeros here. For velocity, these are my zeros. Well, we don't know what happened. Nothing happens out here before time 0. So don't worry about this. And nothing happens on the other time of that. So don't worry about this. But if we look, velocity goes from positive to negative here, negative to positive there, positive to negative there. So these 3 places is where the object's going to change direction, because remember, velocity positive moving right, velocity negative moving left. So we would say at t equals, let's see, 1, 2, 3, 4, 5, 6. I hope that's a 6. I can't see very well. 7, 8, and 9, 10, and 10. The Space Yacht, I guess it's actually probably going up and down. The Space Yacht changes direction because B of t changes sign at, and you gotta write, you can write these down again, or you say at those t values, 6, 8. I like writing them down, 6, 8, and 10. Second one says at what times from 0 to 14 is the shot at the highest. Now this is the absolute max. How high is the ride at that time? Okay, so this is position function, which means I'm doing integral. Well, at time 0, this thing is going to be at 0 because that's where the ride starts. So what this means is we basically got that the position of this object is going to be the integral from 0 to some x of velocity dt. So I am looking for where this object is at its highest place. So this is where I'm going to have to do the areas to get position. I'm going to make my, it doesn't actually say to justify your answer, but the justification would be this object where this is t and this is s of t. So 0 is a critical number because it's an endpoint. 14 is a critical number because it's an endpoint. And then these 2 zeros that we got in there that we just found right here, 6, 8, and 10 are critical numbers. So we need to find the s of t of these. So I'm going 0 to 0. I hope we know that that is 0. So the height's 0 when we start, because that's when we get on the machine. And then for this part, I put 6 in here, so I got to get the area of this trapezoid. Well, I'll make 1, 2, 3, 4. Yeah, that is 6. So this base is 6. 1, 2, 3, 4. This base is 4. And this height, I think that's a 20. This height is 20. So this answer is going to be base 1 plus base 2 times the height of 20, all divided by 2. So let's see, that's 10 times, I'll put 20 on the bottom, it should just be 2, sorry. So let's see, that's 10 times 20, it's 200 divided by 2, that's 100. Okay, so at that time, at times 6, we're at 100 feet. So we're at 100 feet right here, and then we got another 0 here, so I need to get this area. So this is 1, 2, 3 times 2, that's 6, but it's a triangle, so that's, oh, wait a minute, that's not 3 down, is it? We're going by 20, 20, 40, 60. So this is 60 times 2 is 120 divided by 2 is 60, but that's a negative. So we need to take this 100 feet where we were and subtract 60 from that. So we're 40 feet above the ground at 8. And then we're going back up again because velocity is positive. So this is 2 times 40, which is 80, and half of that is 40. So we got to take 40 that we were at here, and we're going up 40 feet higher, so we're now going to be at 80 feet. And then last, we're going to go down, so this is not going to be the minimum, but we're still going to calculate it. So I got 1, 2, 3, 4, and then this is 20, and then that's 40. So 4 times 40 is 160, right? 160 divided by 2 is going to be negative 80, because it's negative because it's below. So 80 minus 80 means we end up back where we were at the start of the ride at 0 feet high. So the maximum, the max height equals 100 feet, because that's the biggest out of all of them, at t equals 6, and I did not remember if it said the time, seconds. And this is the justification if you need it. Find the total distance traveled for the space shot. Okay, now this one is, hopefully we remember, total distance is the absolute value of the integral from 0 to 14 of v of t, the absolute value. So integral means its position. So it's all these numbers, but it's their positive. So we started at 0, we add 100, then we got to add the negative 60, but it's an absolute value of that, so it's plus 60. And then we had to add 40 more to that, so that's still positive 40. And then we had minus 80, but that's absolute value of negative 80, which is 80. And if we add all of those together, we should get 280 feet. Let's see, 100, 280, yeah, 280 feet would be the total distance we travel. Write an expression of the ride's acceleration, velocity, and distance from the ground that are valid from 0, let's say 12. Yes, 0 to 12. So we are supposed to find all this information from 0 to 12. So let's see. Oh no, it says 10 to 12. I couldn't read. 10 to 12. Okay, so we are only looking from 10, 11, 12, from here to here. So I hope we know acceleration is the derivative of velocity, which to us should mean slope. So this slope is rise over run. So I'm going down 1, 2, which is actually down 40, 40 over 2. So this would be down is negative, slope over 2. So my acceleration would be negative 20. Now, if we were doing this, this would be feet per second if it asked for us to do the units, but it doesn't. Velocity from there, is going to be velocity is going to, oh, I tell you what, I'm going to stop the video for right now. Just had a student come in and I will finish this later and put the other one on.